Thank you, Kirill. Witam wszystkich. Będę mówił ten speech po angielsku, żeby bardziej inkluzywny. It's good, right? Okay, guys, I'm going to start because I'm a very happy developer of this game that you see here on screen, 6 Days in Fallujah. So I'm going to show you a short trailer, just a few seconds of the game so you get the idea about what we are talking and what kind of challenges we could have when developing this game, this kind of game. So I guess I'm going to go for the official trailer. Oh my God. Oh yeah, I turned my mobile phone to airplane mode, being a hotspot, forgive me. Okay, 1 second. Where's the mouse? Goes to the left. Wiesz co? Nie, ja mam hotspot, tylko myszki szukam swojej. Okay. Okay, it was here. Alright.
My first raid in Fallujah absolutely told me that we did not know what we were messing with.
It was a daily scene when you go out and see bodies dumped in the trash.
That's where the terrorists start coming in from all over the world, even from the United States.
The world had become accustomed to a bunch of things happening in a bunch of different places, thinking they're all not connected, but in fact, they're all connected. My fellow citizens,
any vote that might lead to war should be hard.
This ain't fiction, man. It's way scarier than fiction.
you have a Marine in one of these buildings, you don't know which one. You have a shooter moving in these buildings, you don't know which one, and you don't know how many. Combat is not about how fast you can react. It's about fire and maneuver and put your squad in position to cause the enemy to have to react.
Security on that roof!
Back, team up!
Get in the hallway! You watch the tunnel!
Taking the tunnel.
Eyeball, that door! Hoorah!
Dak, get ready! Move it!
Open up!
Back up, through here!
Contact! Suppressive fire! Keep it fair! Let fire go! We got him! This is your team, your choices. Get it done. There's so much people don't know about what's really happening here.
Oh, they don't. On this bombshell, I'd like to welcome you to my presentation. So as you see, the game is a co-op. Sorry. It's a co-op game, multiplayer game with AI elements and procedurally generated mission. So this had its specific challenges. Okay, let me turn on. I need to turn on the presentation now. Okay. All right, so now I have to put this window. Okay. my support window. Okay. Today I wanted to show you the journey we went through to create a perfect multiplayer solution for 6 days in Fallujah. Specifically our analysis of peer-to-peer solutions and how to manage host migration. We also talk about dedicated server game hosting. The takeaway you'll have, hopefully, is a better understanding of how different technologies available and benefits along with challenges of different game infrastructure. Breaking it down, we'll go over peer-to-peer as a technology and its challenges, specifically host migration and how that impacts your development resources. Then we'll look at different dedicated server hosting infrastructure options, including bare metal, compute virtual machines, and container instances. But first, a bit about myself. I'm Michał Buras. I'm leading the networking online engineering for 6 days in Fallujah. Our game had a very successful launch and we're continuing to develop it over time. We recently released another update with the AI fire teams that you saw on the trailer. So personally, I have been in game development for 6 years. I started in VR here with Kirill in the company Real World One. It was a VR for industry company, but it wasn't purely games and I wanted to do games. So I joined the multiplayer guys. If you're from game dev, you probably heard about them. And after that, I was working for a short period for Bridge Studios, a small Spanish company that wanted to make an NFT-based game. But I really wanted to do network stuff, and I joined Highwire Games because they needed a networking guy specifically. So why am I here, right? After the initial launch of the game, 6 Days in Fallujah, I was tasked with my team to add host migration for 6 days, as it's key for our experience and for the game to continue being live. What I realized is that there was a lack of information and analysis between different technologies, namely peer-to-peer versus dedicated server hosting. Also, being curious, I wanted to evaluate if peer-to-peer really was the cost-effective solution we keep saying in game dev. Finally, I hope this exploration will help inform others and grow the knowledge available to the game dev community at large, which is more or less what we're doing here. Okay, I realize not everyone in this room might be engineers. So here's a quick overview on the basic of peer-to-peer and how to connect players over network. Peer-to-peer, as they say, it's supposed to be super simple, right? Your game creates a listen server, and with the public IP, you connect all players to the server. Unfortunately, the truth isn't that easy as it seems, because your public IP is not your own public IP. This means that the IP address is shared. Your internet provider groups multiple users under a single IP through a process called network address translation. The only difference is the port number, which is temporarily assigned to you when you request a web page or other resource. For non-engineers, think of the server's IP as an apartment block. However, as there are multiple flats in each building, every time you order a pizza, you are given a unique flat number, and that number changes with each order, and this causes a lot of confusion. So we need to find a mechanism to get a number assigned and share this information somehow with other players. This solution is called a stun server. Think about it as yellow pages. If you want people to be able to find your business, you have to update yellow pages with your current number. Unfortunately, this solution is not secure because our flat number could be shared further, and anyone from the internet could send something to us. Most of the internet service providers find this unsecure and block this kind of traffic. The alternative is a relay server. Your private address is not shared with anyone except the server, which relays information between you and another player. These are almost compute-less servers, but because they require a certain amount of compute power, you have to host them, which means you need a service provider. Which also means is that it's not purely peer-to-peer solution. There are a lot of services available which deliver relay server solutions that we evaluated, but for this presentation I will talk about only 3 that I find the most interesting. Epic Online Services give free relay servers, which means 0 upfront cost and 0 maintenance cost. This solution requires least amount of development. They are cross-platform, have a lobby system, and the only thing you are missing is some matchmaking system. However, you have absolutely no control over how those players are routed. A relay server adds extra node to your game packet that your game packet has to pass through. You see, this is kind of crucial information here because we're talking about peer-to-peer technologies, and you end up the technical implementation of this is a server in between you, something like a dedicated server, right? That introduces additional latency, right? And given the limited number of relays, player might be routed to distant ones based on availability at this moment. This high latency is unacceptable in a commercial game and it leads to poor player experience. Consequently, churn. This directly results in frustrated players on Discord and loss of revenue. EOS also can be vulnerable. This is an example from one of the AAA titles on Steam. It's actually, if you're curious, it's Aliens. You know the Aliens, the movie, right? So it's a big franchise title, right? So basically, a 10-year-old kid can install this application called Fiddler, and he can look up the party data of players in such a big franchise title. So this is a massive amount of risk. So if you intend to use EOS, you have to be very, very mindful what you put inside here. An alternative peer-to-peer solution which I found interesting are WebRTC relays. I discovered this infrastructure option for People Can Fly Outrider stock, and they had an Unreal deep dive presentation a few years ago. In short, it's a good implementation because they reuse relay servers, but they have to modify the Unreal code a lot to cope with it. Also, they had to host the relays themselves. It's custom infrastructure that you need to build, test, optimize, and maintain, which means monthly costs that could have been spent elsewhere. However, it's unclear if they are really that much better in terms of performance to EOS relays. Which brings me to self-developed relays. In one of the projects, the idea was that we can make a relay server in Unreal Engine that will serialize packets, maybe analyze them to prevent cheating. This didn't make any sense at the conceptual level because of additional computational latency and cost. If you're computing, it's not a relay server anymore, right? It becomes a dedicated server. So my recommendation, if you want to have your own relay tech, I just grab a proxy from GitHub, modify it to be runtime configurable. You don't need to implement any kind of packet repetition ordering as your game engine already handles this. But if you take a step back and think about it, at this point, you're not making a game, you're making an infrastructure, right? You're burning money on stuff that isn't helping your game to grow content, right? Or have better features. So what's the point, right? Now, all of these services have a fundamental challenge. You need a mechanism called host migration because a player, remember, we're talking about peer-to-peer games. If one of the players that is hosting the game leaves, right, everyone gets disconnected. You know that, right? It's a fundamental issue you need to figure out because it literally kills the game session, a massive problem for any commercial game where multiplayer is the key. We had a massive problem in 6 days with people randomly quitting the game because, it's a difficult game and people tend to rage quit a lot. And they weren't aware that they are being a host. You can't expect from your game client, regular game player to expect to know what is peer-to-peer and that he is hosting the game. So in 6 days, I've implemented basic host migration using only Unreal Net driver, and it worked very good in its very basic form. I don't want to get too much into detail here since it's only for Unreal geeks. But the whole project required full refactor in order for all the C features to support it. Each small feature, designer blueprint had to be reworked. So there's no silver bullet in implementing this, unless your game engine somehow natively supports it. But this will come with the network bandwidth cost, as all of the players who might become the host have to replicate the game state, right? So, and you're making a peer-to-peer game, so it's kind of a lot of data that you would have to send through to everyone. The takeaway being is that while the upfront cost of making a peer-to-peer game is super cheap, the host migration solution you have to build becomes extremely expensive. So not so cheap at all. All this investigation of different technology and services led us to realize that to use cheap solution that was peer-to-peer, we'd need to build an entire system called host migration, which won't be seamless resolution and poor user experience. Then we'd need to maintain it. So either you hire additional staff or move your project release date. In both cases, you burn money. It's all because you're increasing the complexity of literally each part of the game. Our evaluation is that you would need an additional 1 tester and 1 dev to be purely assigned to reworking all of the features to proceed further with this. This would cost us money monthly around $15,000 and that would grow to maintain it. I want you to remember this question: what else we can get for $15 a month? So next step was to evaluate the other options, namely dedicated servers. And let's compare and do a cost breakdown. But before we go further, let's look at this graph. On the left side, you can see game sessions of 6 days in time. This is real historical data at some point of development on a 24-hour period. How to read this? For an example, red plot is North America East at UTC 0. It has a peak of 33 games. This means that there are 33 servers of 6 days running in parallel. Since our game requires 2 virtual CPU threads, this region to sustain requires 66 virtual CPUs. So if you go to Amazon and you want 62 CPUs all the time in one region, it's going to cost you thousands, right? On the right side, you have a monthly distribution of cost to host such game distribution. As you see, we've got this cool thing called edge gap, which I'm going to talk about in the moment, and it's a really game changer in hosting game. So let's go through each example. First is the most obvious. I have calculated the cost of the peak of each region separately to make as accurate as possible. Due to procedural map generation and very sophisticated AI, our game requires a bit more steam, but 2.2K players daily, well, it's not so bad. And if our game was Valorant, I assume that Valorant, since it's a static map without any procedural generation, it can run on one CPU, it would reach almost 10K. So it's not bad, right? $15,000 for 10K players. Good old bare metal. So this is something when you're going to go talk to the all technical directors, they're going to say, no, don't use cloud computing, go for bare metal. Bare metal is safe, performant, and secure. So, they say that it can fit more performance. In case of my gaming laptop, in case of 6 days, my gaming laptop can run the server on a single logical thread. So the calculation remains the same if I would want to buy bare metal. Maybe something simpler like Valorant could do on bare metal, but I don't know. It never convinces me. So I started Googling container instances as I was wondering if there is any progress in containerized game server tech, and I found those guys. As container instances are fully managed, they do not require any engineering cost. I just upload the game image. I don't care about regions, overhead, or any kind of configuration that I had to do with other infrastructure technology. This is how we discovered EdgeGap, who were the first one to develop it in such a way that it was usable for multiplayer games. So what are those container instances for non-technical people? You build a small package like a zip file and just push it into cloud and it executes somewhere and you don't care where. You know, when you go to AWS, you have to go and set up all those regions. How many CPUs you want on this region? How many CPUs on that region? You know, and when I go and I talk to those, cloud companies, and I ask them, okay, so how do you handle Cape Town? How do you handle South Africa? And they say, we don't. Why you don't? They're not buying as much of our games, so we don't care about their latency, right? So EdgeGap, what is doing, they have like 500 endpoints all around the world, and depending on the IP of the players, they can deploy it at any place on Earth, right? So they kind of solve the problem of the players who are kind of, left out on all the fun because they're not from Germany, right? Another cool thing is to note here that they are not bound to a data center. Oh yeah, this example with Cape Town. So this makes our game inclusive, right? Usually you go for the lowest hanging fruits in terms of game region, but if you add those small locations where people are unable to play because of the high latency, those small berries become a really good meal, right? Since there is a lot of talk here about game monetization, it's a sentence from a different conference because it was super focused on monetization. Okay, so why are those container instances so good? You might argue that AWS has a similar feature, right? Apart from configuring regions and stuff. So let's have a look at this chart I did. The green line is overlapping with the blue line. is the non-averaged real player data, right? So on the green line, it's, players starting a server, players ending play, starting a server, ending, right? When using public cloud solutions, we need to keep an overhead of the game empty servers, right? So we need those, those 8 CPUs here, right? In case of the spikes go up, right? So it's impossible when you go to AWS, right? It's impossible to align your CPUs that you pay for exactly with those players here, right? And when you're using edge-gap, when you're using container instances, you're only paying for this part. You only pay when the players here, right? You have a group of 5 players and they decide, okay, we're going to play right now. They spin up a server. You only pay for the time when the server is deployed and you stop paying when it ends, right? So you're not paying for this anymore. And this is a big game changer. Oh, and there's another thing I have to mention, because why is that? Why do I have to keep this overhead? Maybe I can just spin up a VM here. So the problem is that if you ever used any kind of cloud and you ever used any kind of VMs, you know that spinning up a virtual machine, it takes around 2 minutes, right? So at starting the game server binary, you've got 3 minutes. You can't make players wait 3 minutes for a server that they can go into, right? So that's why we use containers. So containers can start really, really fast. And why they can start really, really fast, right? Because it should be more or less the same tech, right? So what they do, what edge-gap does, is that they pre-cache the image in all those locations. So basically, for non-technical people, you build your zip of your game, right? You push to edge-gap, and they deploy it all around the world. So it's already there, and they already have those VM spin up for you, right? So you generally you ask them to, hey, allocate me server in, I don't know, in Frankfurt, right? And they spin up the container on the VM that's already running. And you don't pay for this overhead because this overhead is shared amongst all of their clients. So that's a big game changer. So, before EdgeGap, everyone was paying for the infrastructure by themselves, and now the infrastructure is shared. And this is what we can get for 15K USD a month using EdgeGap and Epic Online Services. That's our capacity. 36,000 player sessions, right? Oh, sorry, that's Valorant. 500 player sessions. So this is what we can get for 15K USD. And if we were sticking back to the peer-to-peer option for those 15K USD, right, we would have to maintain a solution that would be not as good, right? So thank you for your attention. And
what's the catch? I mean, there has to be a takeaway. If it's so much better but cheaper, I know user experience, the dashboards suffer.
So the problems I had is that since you're sharing a host, right, the L3 cache is shared amongst all the clients, right? So you have no control over this. I mean, you can ask EdgeGap to moderate that. Hey, I don't want to be paired with this and this game because they negatively impact performance. But I think it's a corner case. I mean, I haven't had any performance issues so far. The hardest thing was to get a crash dump from the game because of the security nature of the Docker. Because in order to get a crash dump, you make a system kernel call, right? And within this kernel call, for an example, if your application would load some other libraries that are system libraries, right? It's possible to dump some information from memory from those libraries back into your container. So, yeah. Apart from that, I mean, the image caching, it's not perfect yet. It's a new tag. So we had some issues, for an example, that we had to wait for an hour until our image propagates all around the world, right? But it's in terms of numbers and capacity, it's kind of a game changer. Because right now I'm gonna make my start my own private project, multiplayer project. And I'm gonna go full dedicated servers. I'm gonna pay like, I don't know, $100 for hosting the game. For players that that will be willing to play this game, right? And if I didn't have EdgeGap, I would have to develop some, difficult peer-to-peer solution, right? And the game would be like cranky, right? Or I would have to go to AWS and pay $1,000 and start. Any other questions?
What about any system, anti-cheat system? Is it working the same as in the Amazon cloud, or do you have?
And what is the anti-cheat system of the Amazon? I'm not a security expert, but
I'm not sure. I'm just asking, is it the same for when you're using Amazon cloud or your the Edge system?
okay. So
Is there any security problems?
I don't think so, because in both cases you're running dedicated servers, right? In both cases you have a port open into the internet, some external post that people address you, right? And there's your game binary on the other end of the sport, right? So your server is as secure as your game binary is secure, right? So it's secure as the engine that you're using. So answering your question, in terms of security, EdgeGap is as secure as your binary is secure.
Your comparison on P2P is judged on the assumption that it's you have to pay for maintaining it, but not everywhere the cost is the same. So it could be cheaper, and if there's some already available solutions for other engines, maybe, so it's going to be still much cheaper in this regard. And for other type of games, it can be more suitable, like not for rage quitting games, but I don't know, some cozy co-op games. Still, it's a better choice would be. So I would like to know what are still disadvantages of P2P in those cases, if there are any.
I super agree with you. I know this game, Lethal Company. I don't know if you know this game. Lethal Company is a perfect example where peer-to-peer is just as it is beautiful, right? Because you don't. It's a fun game. You do it for fun. You don't rage quit most of the times, but you don't have the urge of competitiveness cheating, right? And in terms when you're doing anything competitive, you have to go for dedicated servers. Or for an example, in 6 days, if we would stick to peer-to-peer, abstracting of cheating itself, want to do some kind of cosmetics, right? So we're going to introduce some kind of currency in game, right? And if there's anything client authoritative, then it's a massive security risk, because someone can cheat, and you can add a little bit currency or achievement on a peer-to-peer game and then transfer it to dedicated server games. So yeah, it's I think you made a really good point, that it really depends on your genre, right?
Thank you. I really wish that Valve and Counter-Strike 2 as a product would have as much security concern as you. I don't think many persons think in that case for as much security as you.
Well, we're struggling. I mean, here sits the greatest security expert. To be honest, I'm a bit of, it's gonna be okay.
The game is under development.
It's early access. Yeah. It's what is the peak right now? I don't think I can tell 100%, company data, but we had 2,000 CCU last weekend. It kind of transfers to the dedicated, because we're also a single player game. So not all of the players, not all of the players play online all the time.
I was just curious because you have some capacity, a big capacity, and I'm curious how much of it you are using.
Oh, this you mean the chart? The chart that I shown?
No, you just gave an example that you can have like.
Oh yeah, of this capacity. Yeah, exactly. Okay, it's a good point. So we're not using all of the capacity that I mentioned, meaning that our dedicated server cost is below 10 grand monthly for a AAA title. It's so yeah, it's a real game changer.
What about server locations? Do you have any sort of control over it? Like if one player is in US, three others are in Europe, and maybe one in China, can they select a server, or how does it decide?
Brilliant question. So it's going to align to the majority and it's going to try to move to the server as close to the let's call this loose electron example. All right, so you have two players from, I don't know, North America, and you have one from Europe, right? So it's gonna move the servers to east coast of United States, but keep them within United States borders because 3 of the players are from that region, right? So more or less works the same. If you have 2 players from, if you have an equal weight distribution, let's call it a weight distribution, it's gonna spin up somewhere equally. So I've seen like we're still working on our matchmaker, and it kind of does some crazy matchmaking. So we've got one guy from Australia, one from North America, one from Russia, and one from Poland. Almost like in the joke, right? 4 guys riding a car. So, and the server was in Mumbai. I mean, the system, it did its job, right? It found the common place in between those guys that makes the most sense, right? But our matchmaking solution, it needs a lot of fixing. So,
Does it work with China? Like with Great Firewall and
It has to be
does
safer,
Great
so I think, yeah.
oh, it's a good. You're both kind of right. So it works inside the Great Firewall, but you cannot. You won't have good latency from outside the firewall into the China, right? So it's kind of tricky. So actually, it's a topic for another presentation, but it's really good. So Chinese guys use VPNs. They're called game boosters, and with those game boosters, their location is sometimes shown, for an example, Hong Kong or India, right? And it's very difficult for us to matchmake them, to give them the best experience, because we would like to know that they're really from China and spin up a server in China for them. But we also spin up servers in China. If the guy is not using a game booster, or the game booster is, I think, UU game booster, it does not change the player's location, and they all play within China, and it's okay, right? But if you get one guy from India and 3 guys from China, should you spin up a server in China and ignore the India guys, or move China guys to Hong Kong? That's actually what we're trying to figure out right now, and it's kind of, it's matchmaking is not about algorithms and good math. It's about psychology. You won't have idea. You have no idea what's good for players, right? I mean, for one guy, 120 latency can be okay, or like you mentioned, the genre type of the game, right? 120 in a co-op game might be so-so, but on the other hand, in Lethal Company latency, I wouldn't like to run from those mobs with such a low latency, right? So such a high latency. So it's a good topic.
Even the topic. Any free Steam keys?
And if we, God damn, everyone asks that. I have to ask my boss for that.
But you know, if you want to support the developer, it would be nice to try it.
That
Do you have any measures for cost effectiveness at the long tail of the sales? Like to keep the servers running, you need the constant income, and I don't know, in the future the developers would be switched to other projects and the game would get less sales, but the players would be more of them, and you would still need to pay for the servers. Do you have any idea of how you're going to handle that?
it's a very good question. So I've asked that question to my CEO, but as I'm an engineering guy, so I won't get into all business discussions, right? But he answered me that the players usually, your casual player, average player, plays for about 2 weeks a game until he gets bored. So, and I think that kind of makes sense when when you're super into some game, you play it for months, but the other games that you play apart from your favorite game, you play them for 2 weeks, right? So if you do a cost calculation and take the game price, for an example, right now, $23, you can host a lot of games. Actually, for one player to play for 1 hour, it costs 4 cents. Okay, yeah. So if he plays for 2 weeks, approximately 3 hours daily, it ends up, you end up paying, $3 or $5 for the server for this guy, and rest on the top is revenue. I mean, those are my estimations. It's hard for me to go and call and, hey, Peter, you have to explain this game finance. I'm worried about the game finance.
Does your game work on Steam Deck?
Yes, I believe so. I've heard some mentions about the Steam Deck, and I believe it works. Yeah.
Is that
I'll still would prefer free.
It's good engineering. Good engineering does not come for free.
Well, now I know how to do it, so I can just make it myself. Stole your idea.
You said that you can't make players wait 2 minutes for the servers to start, but you wait like 10 minutes in Valorant for the game to start, so I think Riot don't care at all.
It's
Just
more
like-
complicated.
It's matchmaking
Matchmaking.
case. Yeah, it's not the server
It
case.
is much more complicated.
But
I think.
no, first you wait like 5 minutes for you know queue,
Yeah.
and then like 5 minutes on the loading screen.
That's
Ah.
that's weird.
Did you first rewrite your game to support P2P, and then you rewrite it back again to support dedicated servers?
We never stopped supporting peer-to-peer. Oh, wow. Yeah, that's a good question, another. We have a case for peer-to-peer, so we found out that rage quitters are usually random people you play with. So what do? When you use matchmaking and you play with a random guy, you end up on the dedicated server. But when you're playing with your friend, that you know him, right? You go into peer-to-peer game. So we kind of we married two systems, and it's kind of okay. It's super end up being really super cost effective.
Okay, and there is no like gameplay differences because of the architecture you use?
Gameplay wise, it's the same. I mean, Unreal out of the box will support dedicated servers and listen servers, and you're going to write the same code, almost the same code for it. So yeah, we will have we're asking about security and stuff. So we have to still figure out whether we are going to do the same economy for the peer-to-peer games, whether for dedicated server games, like I said, right? Because peer-to-peer is prone to cheating. That's something I'm leaning to, but we're gonna discuss this year.
And have you considered letting the player pick a region?
Oh yeah, we love that idea. I have like this friend. I've inherited the whole networking area of him because he wants to be a generalist, Andrew, and we talk about all the time with Andrew that this auto region selection sucks, and we should make a player to decide where he wants to play. The designers are guys that came from console area, and they're saying that console players prefer everything to be automated. I can't tell. I'm not a console player. Maybe you guys know.